matrices to solve simultaneous equations, as well as getting the inverse of a matrix. So let's go straight to the question. The first part of the question: determine the inverse of a matrix 1, 1, 2, -1. So to get the inverse of a matrix, the first thing we need to do is to get the determinant. So we get the determinant of the matrix, and to get the determinant of the matrix, we get the product of this diagonal, which is 1 multiplied by -1. Then we subtract the product of the other diagonal, which is 2 multiplied by 1. So when you get this product, this is what you get, -1 minus 2. And therefore, the determinant is -3. So that is how you're supposed to get the determinant of the matrix. Now let's proceed and get the inverse. Now to get the inverse of this matrix, we need to, after obtaining the determinant, which is -3, we need now to get the inverse, write the inverse of -3, which will be -1 over 3. Then this is how we interchange these values. Let me get these. So notice this is how we are going to interchange. When you're getting the inverse, the product of these points that are in this diagonal, 1, -1, will be interchanged. So -1 will be here and 1 will be here. Then for the other diagonal, which is 2, negative, this is 2, 1, that one will change the sign. The signs will change, and therefore we'll have -2, and this is -1. So simply that is how you're supposed to interchange. So we can leave the inverse like this, or we can simply multiply out everything inside this bracket by -1/3, which will give 1/3. This is 2/3, then 1/3, and this is -1/3. So that is how you can leave the solution, either when you've multiplied out everything, or simply using the brackets where the inverse of the determinant is outside. Now, after getting that, the next question is now, hence find the coordinates of the point of intersections of the lines. So after working out the inverse of the matrix, these questions are connected to each other. So the solution that we got in the first part will determine how we are going to work out the second part. So simply, we are required to solve these two equations simultaneously. So we're going to begin by organizing these equations in matrix form. And to do that, we're going to arrange the x and the y values to be on a straight line on the same column. This is how we're going to do it. So we have the first equation, which is x plus 2y is equals to 7. The other one, we arrange the x's as the same straight line. So this is x minus y is equals to 1. Now you can see the values of x are on the straight line. You can see that. So you can see the values of x and the y, the straight line. So that is how you're supposed to do it. Then from there, you can extract the coefficients of x and y and write the two equations in matrix form. This is how you're going to do it. So this is a 1, 1. Then the coefficient here is 2, -1. And then you are multiplying this one by xy is equals to 7, 1. So that is, now after we've written these two equations in matrix form, that you can use matrices to solve them. Now when you look at this matrix, it is the same matrix that we have obtained the inverse in the part A of the question, the same matrix. So in order to solve these equations simultaneously, it's supposed to pre-multiply both sides of the equation by the inverse of the matrix. And since we had obtained the inverse of the matrix in the first part of the question, you don't need to get the inverse again. So the inverse was here. So negative a third, and we can simply use these. We can use either these or these. So we pre-multiply. This is what we mean by pre-multiplying. So we have negative third, then we have this is negative 1, negative 1, negative 2, 1. Then multiply the matrix is 1, 1, then 2, negative 1. We have xy. So the right hand again, you have to pre-multiply again, also this one. So negative 1, negative 1, negative 2, 1. And then this is a 7, 1. So simply, that is what we mean by pre-multiplying. So you can see we have pre-multiplied this side by this is the inverse and this is the inverse. Now you notice when you multiply out, this will give the identity matrix. So this side you have 1, 0, 0, 1. When you multiply that, you get the identity matrix, and this is x, y. Now, multiplying the right-hand side, of this, we've done about multiplication of matrices in the previous lessons. So when you multiply the right-hand side, this is what you get. You'll get, this is negative a third, you get negative 9, negative 6. So multiplying xy with the identity matrix does not change anything, so you still remain with xy. This will give, multiplying everything here, negative 9 by negative a third, you get 3, 2 is what you get. And therefore, you can get now the point of intersection will be given by the coordinates. And the coordinate is given by x and y. And therefore, we obtained x. So we have obtained x as 3 and y as 2. And therefore, the coordinate of the point of intersection will therefore be 3, 2. So simply, that is how you're supposed to solve the second part of the question. So simply, when you're getting the point of intersection, we are required to solve the question simultaneously in order to get the values of x and y.